Welcome to our deep dive into a world where AI is like reshaping how we do science.
Mm.
We're going way beyond, how businesses use AI and really looking at how it's being used to solve some of science's like biggest mysteries.
Yeah, it's pretty wild stuff.
Right. And the paper that we're using as our guide today, it's called The Future of Prediction and Analysis with AI, a scientific perspective. It really gets into like the trends and possibilities. It even talks about AI predicting earthquakes, discovering new drugs.
I mean, that's just scratching the surface.
Seriously.
Yeah.
Like AI could even help us unlock the secrets of the universe.
Yeah, it really is pushing the boundaries of what we thought was possible.
Okay, so the paper starts off by talking about AI's toolkit for science. Like it's not just one thing, it's this collection of really powerful techniques, right?
Yeah, think of it like a set of tools, each one with its own special purpose.
Exactly. So you've got machine learning. It's basically teaching computers to learn from data.
Mm-hmm.
Like, you know how Netflix figures out what movies you might like.
Mm-hmm.
That's machine learning.
Yeah, it's all around us.
Then there's deep learning. It uses these like super complex neural networks to find hidden patterns in just massive amounts of data.
Right, that's the one that's getting a lot of buzz these days, those neural networks.
And then there's natural language processing. It's where AI is like starting to actually understand like human language.
And that's crucial for so many things.
But all these things, we kind of see them already in our everyday lives. Like that spam filter that you rely on uses machine learning. Personalized recommendations, that's powered by deep learning. Your virtual assistant depends heavily on natural language processing.
Right. And what's so cool is that those same tools are now being applied to solve like incredibly complex scientific problems.
It's almost like having a superpowered research assistant. Very
Yeah,
nice.
that's a really good way to put it.
The paper highlights how AI is being used to predict things that we thought were like unpredictable. Things like climate change patterns, how ecosystems might behave. It even mentions how AI is being used to model the stock market. It's crazy.
It's like getting a glimpse into the future.
Right. And one of the most striking examples, they talk about how AI is being used to predict natural disasters. They talked about this study where AI actually predicted a major drought years in advance, which, that gives governments time to prepare, potentially saving lives and resources.
It's like having a crystal ball that actually works, or at least, getting closer to it.
That's incredible.
Yeah.
But AI isn't just predicting the future, right? It's also speeding up discoveries in other ways.
Oh, absolutely.
Right.
Take the development of new materials, for example. Traditionally, this involved a lot of trial and error in the lab, which could take years.
Years and years.
Now, AI is being used to analyze vast databases of chemical and biological information. Like we're talking mountains of data, and pinpoint potential candidates for new materials, like with specific properties. It's incredibly powerful.
So instead of randomly mixing things in a lab, AI is kind of pointing scientists in the right direction.
Yeah, it's like having a guide. It gives them a starting point. They don't have to start from scratch.
Wow. That's got to be saving them a ton of time.
Oh, absolutely. It's like hitting fast forward on the research process. And it's not just material science. Drug development is being revolutionized, too. The paper talks about an AI that helped design a new antibiotic in a fraction of the time that it would normally take. And that's huge, especially with the growing problem of antibiotic resistance, right?
It's massive. It's a game changer.
Yeah.
So it sounds like AI is becoming this ultimate lab partner.
Yeah, the best partner you could ask for.
But with all this power, there've got to be challenges too, right?
Absolutely. There are always challenges when you're dealing with something as complex and powerful as AI.
Like what are some of the things that come up?
Well, one of the biggest hurdles is what's known as the black box problem, particularly with deep learning. We see these amazing results, these predictions, but sometimes we don't fully understand how the AI got there. It's kind of a mystery.
Yeah, so it's like getting this amazing advice, but having no idea where it came from.
Yeah. Exactly, and that can be unsettling, especially in science where we value transparency and understanding the process, right?
Right. Like, how do we know if we can trust it if we don't know how it works? Does the paper offer any solutions for this?
It does touch on some emerging solutions. Researchers are working on ways to make these AI models more transparent so we can understand, the reasoning behind their predictions. This is sometimes called explainable AI, and it's a hot area of research right now.
It makes sense, right? If we're going to trust AI with these important scientific discoveries, we need to be able to understand how it's thinking. The paper also mentions another challenge, something about data bias.
Yeah, data bias is a crucial issue to consider. AI algorithms are only as good as the data they learn from. If the data used to train an AI is biased or incomplete, the AI's output will reflect those biases, and that could lead to inaccurate or potentially harmful results.
So garbage in, garbage out.
Exactly. You summed it up perfectly. And scientists are acutely aware of this issue. They're working on ways to identify and mitigate bias in training data, which is crucial for building trustworthy AI systems.
Right. And the paper also mentions that, not every scientist has access to the massive computing power needed to train some of these AI models.
Yeah, that's a real concern. The computational resources required for some of these complex AI models can be quite demanding, which can create a barrier to entry for researchers without access to powerful computing infrastructure.
Right. It creates this kind of like digital divide almost in the scientific community, right?
It does, and it's something that needs to be addressed. The good news is that there are efforts underway to make AI more accessible, including developing more efficient algorithms that require less computing power.
So there are hurdles, definitely hurdles to overcome. But it sounds like there are also solutions in the works.
Exactly. This is a rapidly evolving field, and researchers are constantly innovating and pushing the boundaries of what's possible.
It's really an exciting time to be following this field, with all the challenges and the possibilities.
Absolutely. It feels like we're on the cusp of something truly transformative.
Okay, so we've covered a lot in this first part of our deep dive. We've talked about how AI's toolkit is being used to predict the unpredictable and accelerate those discoveries. And we've also started to touch upon some of the challenges and ethical considerations that come with this technology. But we're just getting started. In the next part of our deep dive, we're going to delve into some of those exciting future directions of AI in science. Stay tuned. Welcome back to our deep dive into AI's impact on science. It's really amazing to see how it's becoming this incredible tool.
For prediction and analysis, even speeding up those scientific discoveries.
Yeah. And we also talked about some of the challenges like that black box problem and making sure that the data used to train these AI models is, really high quality.
Right, making sure it's accurate and reliable so the AI can actually learn the right things.
Yeah. And in this part, we're kind of shifting gears a bit. We're going to look at some of the exciting ways that researchers are, working to address those challenges and shape the future of AI in science.
It's a rapidly evolving field. There's always something new happening.
Exactly. And one area that really caught my attention in the paper is the development of explainable AI. Can you tell us a little more about that?
Oh, yeah. It's fascinating. Imagine, being able to understand why an AI model predicts a certain protein structure or identifies a potential drug candidate.
Yeah, like peek under the hood and see what's going on.
Exactly. Explainable AI aims to create models that not only provide accurate predictions, but also allow us to understand the reasoning behind those predictions, which is huge for building trust and confidence in AI systems.
So no more blind trust in the machine. We can actually see the logic behind its insights.
Yeah, it's like peeking into its thought process.
And that increased transparency, that could lead to even more breakthroughs, right? As scientists kind of gain insights from how the AI arrived at its conclusions.
Absolutely. It's like having a research partner who can not only solve complex problems, but also teach you how they did it, which is invaluable.
It's like an apprentice or something.
Exactly. A very apt analogy.
Okay, so another area researchers are really focusing on is making AI more robust and generalizable. So that means creating AI systems that can function effectively in the real world, where data is often, messy and unpredictable.
Yeah, because the real world is a lot different from a controlled lab setting, right? Things are constantly changing.
Okay, can you break that down for me? What does that mean in practice?
Well, in a laboratory setting, scientists can often control variables and collect really clean data.
Right, it's a very controlled environment.
But out in the real world, things are much more chaotic.
There's noise,
There might be missing data points, unexpected variations, or just noisy data in general. And all that can throw off an AI model if it hasn't been trained to handle those complexities.
It's like training an AI to be a field researcher, not just a lab assistant, right?
Yeah, exactly. We need AI that can adapt to new situations and still make accurate predictions, even when things don't go exactly as planned.
So like in fields like ecology or climate science, where you can't always control the environment. Is that what you mean?
Precisely. Think about those fields like ecology, climate science, or even astronomy, where controlled experiments aren't always possible.
Right.
AI needs to be able to handle the complexities of the real world to be truly useful in those domains.
That makes a lot of sense. Does the paper mention any specific techniques researchers are using to make AI more adaptable?
Yeah, it does. They talk about approaches like meta learning and transfer learning.
Learning and transfer learning. Huh. Those sound pretty intriguing. Can you kind of unpack those a bit for us?
Sure. Think of meta learning as like teaching AI how to learn.
Okay.
It's not just about feeding an AI model data and having it spit out answers.
Right.
It's about giving it a set of learning strategies that it can then apply to different tasks and data sets.
So it's more like you're teaching it how to think, not just what to think.
You got it. Meta learning equips AI to learn new things more efficiently.
So it's not just memorizing facts, it's learning how to learn faster from new data. That's really cool.
It is, and it's a game changer because it makes AI more flexible and adaptable. And then there's transfer learning,
Okay, what about that?
which is another fascinating approach. In transfer learning, an AI model trained on one task can apply its knowledge to a different but related task.
Oh, okay. So it's like taking what you've learned in one area and applying it to a new challenge.
Exactly. It's about leveraging existing knowledge to solve new problems.
Can you give us an example of how that might work in science? Like, how is that being used?
Absolutely. Imagine an AI model that's been trained to recognize patterns in medical images.
Okay, yeah, like for diagnosis, right?
Yeah, exactly. So with transfer learning, we might be able to take that same model and apply it to analyze, say, astronomical images or even geological data.
Whoa. So you're basically saying that model could then look at, like, pictures of space or, like, rock formations.
Precisely. The AI can leverage its existing knowledge about patterns and apply it to a completely different domain.
That's mind-blowing. It's like having an AI student who can take what they've learned in one class and apply it to a completely different subject. It's like they're actually learning.
A very astute observation. These techniques are unlocking incredible possibilities for AI to contribute to a wider range of scientific disciplines, and that's what makes it so exciting.
Right. So it seems like the overarching theme here is that the future of AI in science isn't about replacing human researchers. It's more about creating this, like, powerful partnership between humans and AI, right?
Absolutely. The paper emphasizes this point beautifully. It's not about humans versus machines. It's about human intelligence and artificial intelligence working together.
Teaming up.
Yeah, each complementing the other's strengths.
It's like a scientific dream team.
Yeah.
Humans bring creativity, intuition, and deep domain expertise to the table, while AI contributes its computational power, speed, and ability to discern patterns we might miss.
I like that. A scientific dream team. Imagine a world where AI can rapidly analyze massive data sets and identify promising research avenues.
Yeah, and then the human scientists can come in and design the experiments, interpret the results, and draw those meaningful conclusions. Right?
Exactly. It's a beautiful synergy.
So it's a future where AI is basically empowering scientists to make discoveries faster, ask bolder questions, and tackle some of the most complex challenges facing humanity.
Challenges like climate change, disease outbreaks, the quest for sustainable energy sources, and so much more.
It's almost like AI is giving us, like, superpowers in a way.
It is. AI can be a powerful tool in helping us address these pressing global issues, that's for sure.
It really is both exciting and a bit daunting to contemplate all the possibilities.
It is. But one thing is clear. The fusion of AI and science holds immense potential for positive change, and that's what keeps us going, keeps us exploring and pushing the boundaries.
Okay, so as we kind of wrap up this part of our deep dive, let's leave our listener with a thought-provoking question to kind of ponder.
Okay, here's one. If you could ask an AI scientist anything, what would it be? What burning questions do you have about the mysteries of the universe, the potential of AI, or the future of scientific discovery?
Yeah, take a moment to reflect on that question. What would you ask? We'll be back in the final part of our deep dive to explore some concluding thoughts and encourage you to continue your own exploration of this fascinating topic. Welcome back to the final part of our deep dive into, how AI is really revolutionizing the world of science.
Yeah, we've come a long way in this deep dive, haven't we? Exploring AI's incredible toolkit, seeing how it's being used to predict the unpredictable, speeding up those discoveries.
We've covered a lot. And now, as we kind of wrap up, let's take a step back and think about what it all means for you, the listener. Like, what's the takeaway here?
Yeah, how does this impact you? Well, one thing that really stands out from our exploration is the sheer scope of AI's potential impact, like across the board in science.
It really is mind-boggling.
Yeah.
AI is no longer just this tool for, crunching numbers. It's becoming a true partner in this whole process of scientific discovery.
Yeah, like a collaborator,
Yeah.
helping us ask those bigger and bolder questions, tackle more complex problems, and just really speed up the pace of scientific progress in ways that, honestly, we never thought possible before.
Think about fields like medicine. I mean, AI is already changing the game there, right?
Oh, absolutely. It's being used to detect diseases earlier, develop those personalized treatments that are tailored to an individual's genetic makeup, and even design completely new drugs like from scratch.
It's incredible.
It is.
Or consider climate science, where, AI is helping us grapple with one of the biggest challenges facing humanity, right?
Yeah, climate change. It's a huge one. And AI is being used to model those complex climate systems, predict those extreme weather events with, better accuracy, and explore potential solutions to um, mitigate the effects of climate change, which is really important work.
It is. And, let's not forget astronomy. I mean, AI is helping us unlock the secrets of the universe in a whole new way.
From identifying new celestial objects to studying like the evolution of galaxies, it's mind-blowing. AI is giving astronomers these powerful new tools to really explore that vastness of space.
It's a whole new era of space exploration,
Hmm.
really. I mean, it's just clear that AI is poised to transform virtually every scientific discipline, like opening up these new frontiers of knowledge and understanding that we didn't even know existed before.
And the pace of discovery is just accelerating. It's really an exciting time to be alive,
It
honestly.
is exciting. But, as we navigate this new era of AI-powered science, we need to, I think, proceed thoughtfully, right?
Eh,
Responsibly.
Oh, absolutely. I completely agree.
We can't forget about those ethical considerations that we talked about earlier. I mean, they're essential to ensuring that AI is, really used for the benefit of humanity and our planet.
It's not just about the technology itself, it's about how we use it. And that's where the ethical considerations come in. We need to be vigilant about protecting data privacy, addressing those potential biases in algorithms, and carefully considering the consequences of AI-driven decisions, especially in areas like healthcare and environmental policy, where the stakes are so high.
Right. Those are areas where, you really can't afford to make mistakes.
Exactly. And AI is a powerful tool, but like any tool, it can be used for good or for, not so good purposes.
It's a double-edged sword.
It is.
Yeah.
And the choices we make today about how we develop and govern AI will ultimately shape the future of science and really the future of our world, right? I mean, it's that big of a deal.
So as you continue exploring the world of AI and its impact on science, here are a few key takeaways to keep in mind.
Okay. What would you say are the most important things for listeners to remember?
First, remember that AI is not a single entity. It's a diverse collection of tools and techniques, each with its own strengths and limitations. So it's not this monolithic thing. There's a lot of nuance there.
Yeah, don't oversimplify it.
Right. And second, approach AI with a critical and discerning eye, right? Question its assumptions, be aware of those potential biases, and really demand transparency in how it's being used and why.
Yeah. Ask those tough questions. Don't just blindly accept the output of an AI system. Always think critically.
Exactly. And third, embrace that collaborative potential of AI.
Right.
See it as a partner for human ingenuity,
Yeah.
a force multiplier for scientific breakthroughs. It's not about replacing humans, it's about augmenting our capabilities.
Right. Working together to achieve something greater than we could alone.
And finally, this is really important. Never lose sight of the ethical implications of AI. We need to ensure that its development and use are guided by, principles of fairness, accountability, and the well-being of humanity and our planet.
Those are the guiding principles that should always be at the forefront of our minds as we venture further into the world of AI.
Exactly. So as we conclude this deep dive, we want to leave you with one final thought-provoking question, something to kind of ponder as you go about your day.
Okay, here it is. Imagine a world where AI could help us predict and prevent the next pandemic. Would you trust its judgment? What factors would influence your trust in such a powerful technology?
It's a question that really goes beyond, the technical aspects of AI. It kind of delves into the heart of human values, right? Trust and this complex relationship between science and society.
It's a big question, but it's one worth considering. We encourage you to continue exploring this fascinating intersection of AI and science, engage in thoughtful conversations about its implications, and just, stay curious about the possibilities and the challenges that lie ahead.
Thank you for joining us on this deep dive. We hope it sparked your curiosity and given you a glimpse into the transformative power of AI and science. It's been a pleasure exploring this with you.
And as always, stay curious, keep exploring, and never stop asking those big questions.